Hello to everyone. Welcome back. Artificial Intelligence class, Unit 3, we are going to discuss. Unit 3 is about adversarial search problems and intelligent agent. Adversarial search methods, gaming theory, min-max algorithm, alpha-beta pruning, constraint satisfactory problems, and then crypt arithmetic puzzles, CSP as a search problem, intelligent agent, rationality and rational agent, performance measures, rationality and performance measures, flexibility, intelligent agent, task environment and properties, type of agent. All this we are going to discuss about in this unit. First, we will discuss about adversarial search problems and intelligent agent. In adversarial search methods, we are going to discuss about game theory, min-max algorithm, alpha-beta pruning. Adversarial search, the definition is, it searches in which two or more players with the conflicting goals are trying to explore the same search space for the solution, are called adversarial searches, often known as games. Types of games in AI are perfect information, imperfect information. With respect to that, they will be having deterministic and chances moves, change chance moves. So if it is deterministic and perfect information, examples are chess, checkers, Go, Othello, and chance moves with perfect informations, Bakiman, and then deterministic imperfect informations will be battleships, blind, tic-tac-toe. Chance moves with imperfect information will be bridge, poker, etc. So type of games in AI, perfect in with respect to perfect information, imperfect information, deterministic games, non-deterministic games. The games of AI has been divided into. If you see what is a perfect information is, a game with perfect information is that in which agents can look into the complete board. So agents have all information about the game and then they can see each other moves also. Examples are chess, checkers, Go, etc. If you consider imperfect information, if in a game agents do not have all information about the game and not aware with what's going on, such type of games are called the game with imperfect information such as tic-tac-toe, battleship, blind, bridge, etc. If it is a deterministic games are those games which follow a strict pattern and set of rules for the games and there is no randomness associated with them. Examples are chess, checkers, tic-tac-toe, etc. And non-deterministic games. So non-deterministic games are those games which are unpredictable events and has a factor chance or luck. So this is introduced by the dice or cards. Such a kind of games are called as non-deterministic games. Examples are Pokemon, Monopoly, and Pocus, etc. are called as non-deterministic games. Such games are also called as stochastic games. And what do you mean by zero sum game? A zero sum games are adversarial search which involves pure competition. In zero sum game, each agent's gain or loss of utility is exactly balanced by the losses or gains of utility of another agent. One player of the game tries to maximize one single value while the other player tries to minimize it. Each move by one player in the game is called as play. Chess and tic-tac-toe are examples of a zero-sum game. What is a zero-sum game in depth is zero-sum game involved embedded thinking in which one agent or a player is trying to figure out what to do, how to desire the move, needs to think about his opponent as well. The opponent also thinks what to do. So each of the players are trying to find out the responses of his opponent and trying to play the game. What is adversarial search methods? Adversarial search is a search based on game theory agents, that is competitive environment. So according to game theory, a game is played between two players. To complete the game, one has to win the game and the other loses automatically. Such conflicting goal adversarial search is referred. Game playing technique, those games human intelligence and logic factor excluding other factors like luck factor. For example, tic-tac-toe, checkers, chess, these are all example for adversarial search methods. And techniques required to get the best optimal solution are pruning heuristic evaluation function. What do you mean by pruning is it is a technique which allows ignoring the unwanted portions of a search tree which makes no difference in its final result. Whereas a heuristic evaluation function is that allows to approximate the cost value at each level of the search tree before reaching the goals node. To play a game, we use a game tree to know all possible choices and to pick the best one out. And for formalization of the problem, we will have several parameters: initial state, players, actions, result, terminal test, and utility. What is the initial state? It specifies how the game is set up at the start. Players, it specifies which player has moved in the state space. Action means returns the set of legal moves in state space. Result is can be referred as a S, A. It is a transition model which specifies the result of the moves in the state space. Terminal test is a true if the game is over, else it is false at any case. The state where the game ends is called as a terminal states. Utility, it is involved with the functions s, p. A utility function gives a final numerical value for the game. When the terminal states are s and player is a p is referred. It is also called a playoff function. The outcome would be a win or a lose or a draw. And its a play of values are +1, 0 or off. For example, for a tic-tac-toe problem, the utility values could be +1, -1 and 0. Game tree. What do you mean by game tree? A game tree is a visual representation of every action and the consequences that can be made in a two-player game when using adversarial search in artificial intelligence. The game tree begins with the beginning state of the game, and each node in the tree represents a different state of the game. These states include about details about which player is taking their turn, the layout of the board, and other pertinent information regarding the game. The game tree is frequently used in conjunction with search algorithms like min-max or alpha-beta pruning to determine a player's best course of action under the assumption that the other players would play similarly well. The search algorithm can decide the best move for a player by examining the game tree and considering all feasible moves and outcomes. For example, consider Amy and Bob playing a rock, paper, scissors game against each other. Each participant in this game simultaneously selects one of the three possibilities: rock, paper, or scissor. So you can portray this as in terms of a tree with respect to allies, rock, paper, and scissor options it has got. And then the Bob chance next after allies, and they'll have an option with respect to rock, three different options of rock, pepper, and scissor. With respect to the paper, coined by allies, Bob will be having three different options or three different branches or rock, pepper, and scissor. Similarly, when allies has a scissor, and Bob again can have the three combinations of rock, paper, and scissor. So, with respect to allies as a rock and Bob as a rock, the utility value can be referred as 0, 0. Similarly, when allies had a rock and Bob had a paper, as per the game, it is -1, 1. Minus will be allies value, and Bob will be +1 will be a Bob value. So the first suffix indicates the allies value, and the second suffix indicates a Bob value, which means minus indicates the allies is losing, and plus indicates that allies is winning. And game tree example with respect to tic-tac-toe problem. For example, in chess, a tic-tac-toe, we have two or three possible outcomes, either to win or to lose or to draw the match with values +1, -1 or 0. So game tree, if you look into the tic-tac-toe game tree, it will be having edges, moves taken by the players. First player will be referred as a max. Suppose consider it as a max. The two players that are involved in tic-tac-toe are X and O. If X is considered as a max and O will be considered as a min. Alternatively, max and min will be playing its options. So first max will be started playing. So started expanding its nodes so that min will started playing with respect to the next options. So after X played and X in a particular cell, and min can able to place its O value anywhere else among the other 8 columns of this 3 cross 3 matrix. So all the options can be explored. Similarly, next, when it comes to max turn, then max can see that if x is already placed here, o is placed here, where it can again place x in order to win the tic-tac-toe problems. They can either win by cross diagonally if they have continuous x's, or horizontally or vertically if they consecutively have a 3x's, then they are able to win the games. So if x is winning, and its utility value will be +1, and if x is losing, the utility value of the game is referred as -1, and the draw means it is utility value will be a 0. So same thing I explained here. Two types of algorithms in adversarial search. In a normal search, we follow a sequence of actions to reach the goal or to finish the game optimally. But in adversarial search, the result depends on the players, which will decide the result of the game. So it is also obvious that the solution for the goal state will be an optimal solution, because the player will try to win the game with the shortest path under limited game time. So there are two types of adversarial search algorithms. They are min-max algorithm and alpha-beta pruning algorithm. What is the difference between game playing versus search problems? Game theory and search problem. What is the difference? They are unpredictable opponent, specifying a move for every possible opponent reply. And also it has a time limits. Unlikely to find a goal, must approximate. These are all the different features of your game theory compared to the problem solving algorithms, which we have already discussed in the previous 2 units. So formal definition of a game, they are defined with respect to different parameters: initial state, successor function, terminal state, utility function. Successor function, it returns a list of pass, move, and state. Terminal test determines when game over. Terminal status, state where the game ends. Utility function is the objective function or payoff function. It is going to gain a value at the end result. Based on the end result of the game, the values are being assigned or allocated. What is the min-max algorithm? Min-max algorithm is a perfect play for deterministic two-player game. Max tries to maximize score, min tries to minimize its max score. A goal is move to position of highest min-max value and to identify best achievable payoff against best play. The rules of min-max are a goal of a game tree search, that is to determine one move for max player that maximizes the guaranteed payoff for a given game tree for max. Regardless of the moves the min will take, the value of each node, max and min, is determined by the values of its children. Max plays the worst case scenario. Always assume min to take moves to maximize his playoff. Example, to minimize the payoff of max. For max node, the backed up value is the maximum value that will be associated with its children. For a minimum node, the backed up value is the minimum of the maximum player whose value is associated with its children. The min-max procedure is generate the whole game tree to leaves. Apply utility function to leaves. Uses a DFS for expanding the tree. Backup values from leaves towards the root. A max node computes the maximum value from its child values. A min node computes the minimum value from its child values. When value reaches the root, optimal move is determined. So this is how a min-max algorithm works with respect to a tree or a branch with the example problem. So if you consider this tree, the values that are given at the end of this node are referred as a utility value or evaluator value or evaluator function. So with respect to this, 2 and 7 are the children for this particular node. So among 2 and 7, the min player will be chosen by this particular node. So they are the children for this parent node. So parent will decide which children should be chosen away. So the first one will be default, we refer it as Until otherwise stated, we refer it as max player, so that the second pair will be level 1 will be allocated to, level 0 is allocated to max player, level 1 will be allocated to min player, and again level 2 will be for max player. So this is a minimum function or minimum player. So he will choose the minimum value among the its two children, so 2 will be chosen here. Similarly, if you tell me 1 and 8 of this utility value, this minimum player will choose what? 1. And then here, which player is there? Max player is there. So max player, whose children are what? 2 and 1. As a max player, it will choose what? Among 2 and 1. It will choose 2. So this is how the minimax search algorithm will works. And the 2 will be followed from where? This 2 and this 2 and this 2 is being here. So the path for finding this 2 on this source node is this one, right? 2, 2 and 2. So this is our path after min-max search algorithm. So min-max search algorithm can be considered a two-player game tree in which the static scores are given from the first player's point of view. Apply the min-max search algorithm and compute the value of the root tree. This is again another problem. Among 2 and 3, the 3 will be chosen because A is a maximum player, and the next level is going to be minimum, and then the next level is going to be maximum, right? So these are all maximum players. They'll try to choose maximum from its children. So from the end node, destination node, or utility values, or payoff matrix values, the parent node or max player will choose what? Maximum value among them. So among 2 and 3, 3 has been chosen. Among 5 and 9, 9 will be chosen. From 0, 0 is directly has been assigned, and 7 and 4, the 7 has been chosen. Similarly, 2 and 1, 2 will be chosen, and here also for 6 and 5, the 6 has been chosen. Next, these parents are what? This particular level is being played by which player? Minimum player. So since it is a minimum player, they will choose minimum value from the from its children. So among 3 and 9, what it will choose? 3. Among 0 and 7, what it will choose? 0. Among 2 and 6, what it will choose? 2. Again, this is a what? Max player. So max player will choose maximum value among its children. So among the 3 children, who's having the maximum value? That is B node. So which is 3. So 3 will be assigned to this A, and the what is the destined path is this 3 is coming from where? From B. Again for B it is coming from E, and for E again it is coming from M. So what is the path for the previous problem is this is the path of searching min-max algorithm for this particular example. Similarly, this example also can be able to solved. And properties, parameters, evaluation parameters analysis of min-max algorithm is whether it is a complete. Yes, it is a complete if tree is finite only. And whether it is an optimal. Yes, if tree is complete, then it becomes an optimal. Time complexity is as like what? Depth first search, because it is going to search all the values based on depth only. So it is order of B power M, where M is the maximum depth of tree, B is the branching factor. Space complexity is what is order of B into M. So it is almost same like what? Depth first search. These are the limitations. Thank you all for watching.